Hello, everybody, and welcome to our webinar today on direct air capture. This is our third episode this week in sequestration week 2. We'll be talking about technology to help pull carbon out of the air. We've got two amazing panelists with Deepika Nagabhushan from Carbon Direct and Natalie Khtikian from Climeworks, who we'll be introducing more thoroughly in a minute. My name is Brian Stewart from Electrify Now, and my partner Joe Wachunas will be hosting today. So thank you for tuning in. We're excited about today's episode. In case you haven't joined us before, and we're Electrify Now, we're an all-voluntary organization. We are working to help everyone understand their role that all of us play in helping to transition our energy systems from fossil fuel-based to clean renewables. And we try to keep it really simple for people in terms of how to take action. The first thing to do is make sure you get clean electricity into your house, and it's possible with all sorts of ways, whether it's green power plants or community solar or rooftop solar, and then replacing all the devices in your home that burn fossil fuels so you can electrify your home with clean, awesome electric solutions. Electrify your transportation, whether that's an EV or electric bike. And then, of course, we have to bring everyone along with us on this journey, even those who might have struggles to electrify, and particularly the low-income and high-impacted communities. So that's what we call Electrify Everyone. So doing this will, of course, reduce your carbon emissions, but help accelerate the transition to clean energy for everyone. There's more information on our website about that. Also, just want to shout out to our coalition. There's over 40 organizations that have joined us in our quest to help promote the benefits of electrification. If you are interested in having your organization join us, please let us know. You can email either Joe or I. Our information is on our website, and we'd love to have you as part of our coalition. Also want to just say thank you to all of you who donated to the Electrify Everyone Fund. That's a charity that we set this product up with Community Energy Project. They're a local nonprofit here that works with low-income families, and this Electrify Everyone Fund is specifically set up to help us fund paying for free heat pump water heaters to install in homes that have aging gas water heaters. Low-income qualified homes helps these families save hundreds of dollars every year on their utility bills and avoids over 25 tons for each carbon for each water heater that's installed, and we've put in over 50 of them now. Last year, we just through the webinars, we raised almost $4,000, and I think so far this week, Joe's in about $500 we've raised from our webinars this week.
I think we're approaching 600. Yeah, so
okay, that's great. And just a reminder that everyone who donates to our webinars this week is qualifies for a kind of raffle we're doing for 2 free books. Climate-Wise Landscaping, you see down there in the corner, written by one of our panelists that we're going to have on our show on Friday, Ginny Stiebel. And I'm really excited about that. It's a great book, we know from experience, and also another shout out to join us on Friday if you're interested in that topic. So thank you for all the donations. And so here we are, sequestration week 2. We had a session on sequestration a year ago. We covered slightly different topics. We had great turnout from that, and this year we've got a great lineup of programs. On Monday we started with an overview of carbon sequestration. We had a great session on regenerative agriculture yesterday. Both those are available on our YouTube channel if you're interested in catching up on those, as is all the sessions from last year. Today we'll be talking about direct air capture, of course. Tomorrow we've got oceans, and then climate-wise landscaping on Friday. We've had amazing turnout. I think we've got people from like over 1,900 people this week from over 40 countries, 75% in the US and 25% international. If you're willing, please let us know where you're tuning in from. You can let us know in the chat, would be great. And then we're gonna run a little poll here just to let people just let us know where they're coming from in terms of their interest in this topic. It's just really great to know a little bit more about our audience. I guess I forgot to do that while I was talking about the episodes this week, but let's see. That was a little hiccup. Okay, here's the results. So it looks like 34% of you are from the general public. We have 10% from the energy industry, 9% from government, 22% from nonprofits, and 7% from academia, and then 18% from other. So thank you for that information. It's always just helpful to know where everyone's coming from. All right, so that takes us to our topic. And just, Joe, why don't you just start us out with why we're even talking about sequestration in the first place?
Yeah, perfect. Well, hope you've been able to join us and for our other webinars this year or last year. But, at Electrify Now, we are first and foremost focused on our top priority, which is reducing our carbon emissions as soon as possible. All these human-caused carbon emissions that come from fossil fuels, be that natural gas, oil, or coal. Of course, we all agree that that is our top priority, and we need to transition to cleaner electricity options such as electric cars, heat pumps and heat pump water heaters, and then renewable energy, and that will drastically reduce our carbon emissions. So we just want to highlight that that is our top priority. But as we do that, in tandem, we have an enormous amount of legacy carbon emissions that have been accumulating in our atmosphere for the last couple hundred years. Scientists from the Intergovernmental Panel on Climate Change estimate that by 2050, we'll need to reduce by 5 to 15 gigatons of carbon dioxide per year. We'll need to remove that from the atmosphere. Now, if you're like me and your eyes glaze over, and what does that number really mean? Well, the U.S. emitted in 2025 gigatons of carbon dioxide. Now, the 5 to 15 number that we'll need to remove is a global number, but just to give you an idea, the 200 million cars, the 120 million water heaters and furnaces that we have out there, all that in 2020, all that carbon dioxide and equivalent will need to be removed by 2050. So we've got 3 decades to get to that scale of carbon removal. And so, our top priority is reducing our carbon emissions really quickly. But in tandem, we want to be talking about carbon sequestration as well. And we've talked a little bit about both natural climate solutions, natural ways to remove carbon dioxide, as well as artificial ones. So last year we had a whole webinar on forests. Yesterday, hopefully you joined us for our great webinar on regenerative agriculture. Tomorrow we'll be talking about oceans as a possibility of removing carbon dioxide. In future webinars, we'll talk about enhanced weathering. Last year we did industrial carbon capture and storage. And then today's focus will be on direct air capture, where we're pulling carbon dioxide out of the air directly. Now, we want to preface this by saying we know that sequestration kind of any shape or form can be controversial. We've seen in some of our previous webinars that some fossil fuels companies are really invested in artificial sequestration in order to keep doing their business as usual and keep burning fossil fuels. So we want to recognize that, and our panelists will talk about that today. But these ways are also essential because we know that in addition to eliminating carbon, our fossil fuels, we will also have to sequester some carbon from the atmosphere. So today we're going to be talking about direct air capture, taking carbon dioxide directly out of the atmosphere. It's a difficult process, of every million molecules of air, 400 are carbon dioxide. So we'll talk about what is direct air capture, what are the technologies that we're doing and how mature are they? What are the opportunities and what are some of the barriers to scaling this technology from where it is right now? Who are some of the leaders in this technology? And we'll hear from one of them today, Climeworks, and what projects are in development. Oh, one more. And can individuals help in supporting this technology? This is something we're very excited about. So without further ado, let me introduce our panelists today. First, we're going to hear from Deepika Nagabhushan, who presented with us last year on industrial CCS. Deepika is the client manager for Carbon Direct, where she advises clients on meeting their carbon management goals using carbon removal projects. Prior to Carbon Direct, Deepika led the Clean Air Task Force Carbon Capture and Sequestration Program, where she was advocating for policy to advance rapid deployment of CCS infrastructure. She's got a master's in science and sustainability from the Earth Institute at Columbia University and a BS in business management from Bangalore University in India. And then after Deepika, we'll hear from Natalie Khtikian. Excuse me, Natalie, for butchering your last name. You'll have to help me with that. She's the market manager for Climeworks, a Swiss company specializing in technology to filter CO2 directly from the ambient air and store it permanently. Climeworks has opened the first and the largest direct air capture plants in the world, so we're so excited to have them on today. Natalie's responsible for developing the voluntary carbon market for this technology in North America. And she's a graduate of UC Berkeley and holds an MSc in microbiology from the University of Victoria, where she studied the effects of climate change on oysters. She's worked at Wildfire, Waze, and Google before joining Climeworks. So excited to have our panelists today, and I will kick it over to Deepika.
Thanks so much, Joe, and thanks for that introduction. I actually got to learn something about Electrify now, so thanks, Brian, for your slides as well. Let me share my screen. Oh, wait, I have 1 second. Okay, you can see my screen. I'm going to go into slideshow mode now. Is this good? Can everyone see a full screen?
Yes.
Mm-hmm. Looks great.
Well, all right. Hi, everyone. I'm Deepika, and Joe already introduced me, so I don't think that I'll waste any time adding anything to that. Maybe I'll just introduce Carbon Direct a little bit more. Carbon Direct is a 3-year-old organization led by Jonathan Goldberg. We're actually currently growing really fast. We used to be really small, and I joined recently, and we're a carbon management advisory firm, but also we have an investment fund. I'll say a little bit more about that in the next few minutes. We invest in climate solutions, including direct air capture, sequestration, and other utilization as well. And on the advisory side, we help clients such as Microsoft and Alaska Airlines, just to name a few, to manage their carbon commitments and sort of help them with cutting edge knowledge and access to the market. With that, today's presentation, I want to cover a few things. I want to talk about what direct air capture is and what also it is not, why we need it, how much and when, and also what is helping DSE deploy right now and what more is needed to further that deployment. First off, before we go any further, I want to make the most important statement that I think that maybe addressing some questions that might be on many audience members' minds. Direct air capture is a type of carbon dioxide removal, and carbon dioxide removal as a suite of solutions is not considered a substitute for carbon mitigation. We need both. One cannot, neither mitigation nor carbon removal alone can get us to our goals of meeting 1.5 degree, limiting our temperature rise globally to 1.5 degrees Celsius. And it is, sometimes the conversations are around whether or not carbon removal should be done right now. But the important point to remember is that we need both, and neither can. We need both reductions to zero and go negative. We need carbon removal, and direct air capture is one type of it. Direct air capture is an engineered approach to carbon removal. So as you can see, carbon removal approaches span a spectrum, starting from nature-based, which includes things like afforestation, reforestation, improved forest management, blue carbon like mangroves, peatland, wetland restoration, and also soil carbon, which is more agriculture based. There are hybrid solutions in between, which is in between the nature and engineered solutions, which tend to look like biochar, which is basically using pyrolysis on biomass and turning it into biochar that will sort of be a steady state, carbon that will just remain in a solid state. Bioenergy, which is either hydrogen as energy or electricity as energy coming from biomass, but with carbon capture and storage so that the CO2 doesn't go back in the atmosphere. Carbon mineralization, which I'm sure Natalie is going to speak a little bit about in her presentation. And of course, on the far other side of the spectrum, we have engineered solutions like direct air capture and ocean alkalinity enhancement. Direct air capture cannot be looked at just by itself. It needs to be combined with a mechanism to store the CO2 permanently. So it's actually, several times you'll see abbreviations either as DAC or it's DACS, which is direct air capture and storage. So when I say DAC, I kind of do mean storage as well. Okay, so while we have a spectrum of solutions within the carbon removal solution set, why is direct air capture unique, or what does it really bring to the table, and where does it sort of what is its value relative to the remaining, relative to the other solutions? And I wanted to show you this slide just to sort of highlight that point. These, the image that you see on the screen are 4 different scenarios that are modeled by the IPCC to meet 1.5. And all 4 scenarios do meet that goal, but you'll see that there are different scenarios in the sense of how much yellow you'll see in negative emissions, and the yellow represents bioenergy CCS, which we just discussed. The thing about the range of bioenergy CCS that is modeled is that it is practically impossible to do all of that with just BECCS. What tends to happen with these models is that BECCS tends to be this catch-all for negative emissions. And in reality, 10 gigatons or 20 gigatons of BECCS is nearly impossible to do, or that it would be impractical to do it because it would take almost half of global cropland. And that is sort of the land use implication of certain types of carbon removal. While they will be necessary to do at a certain scale, they can't be doing all of the heavy lifting, because that will then sort of push against boundaries of land use and available land, which is where I think direct air capture really comes in. And I wanted to sort of use that as a backdrop to show why direct air capture can address that kind of an issue. It is a highly scalable technology. It does not have any technical constraints in terms of feedstock, because the feedstock is air. It just needs electricity. Different types of direct air capture technologies will vary in how much energy use they will have. But in general, there are no technical constraints as to how much you can build. As long as we can figure out how to do it cheaply and fast, we can do as much as we want, wherever we want it. As long as we can find a way to transport the CO2. So in general, that is the value that DAC brings in the spectrum, in this sort of suite and portfolio of carbon removal solutions. Very briefly, I'm not an engineer, so I want to try and keep it super simple about telling you what direct air capture really is, and maybe Natalie will address some of this in her presentation as well. In general, direct air capture absorbs CO2 right from the air, uses some sort of chemical formulation, either in a solid form or liquid form, and that allows CO2 to bind with that solution or that chemical, and then you kind of separate them in a controlled fashion such that you can capture the CO2 and then reuse that solution if possible, to the extent possible, to capture more CO2, and then capture CO2, and then turn it either into a solid, utilize it in some form, which is basically amounting to recycling, not necessarily removal. But to remove, you have to completely permanently remove it. Like it could be in geologic storage, it could be in mineralization mechanisms and other such options. As Joe already mentioned, while we talk about CO2, increasing CO2 emissions in the atmosphere as the biggest problem for climate change, it's sort of like a paradigm to think how little CO2 actually is in terms of percentage in the atmosphere. It is 0.04%, which is basically 400 parts per million. And so, the amount of energy that it could take at scale kind of is immense. And that means that it is really important to have clean electricity and also cheap electricity to run this. It'll determine where it gets deployed. I wanted to show a map of where it's currently being deployed. This is a map developed by Carbon 180. And if you're interested, I highly recommend following that organization. They do a lot of work in this space. you'll see how some of these projects are kind of small scale, but that is sort of this play today. That is the lay of the land today. It is being implemented, but it is in pilot stages, it's in small scale stages, but we're on our way to sort of increasing that deployment to make them bigger. You'll see at the bottom in Texas, you have one project that's under development, which is 1 million tons per year. This is a rendering of what that looks like. This is a company called Carbon Engineering that is licensing this technology to a company called 1.5 that's developing this project. It looks a little bit like air conditioning units, which is kind of what I think that they are borrowing from in terms of design. They hope to capture 1 million tons a year. It is so far, by far, the largest project in terms of yearly capture rates that has been announced. And it's expected to come online either this year or next. I don't have an updated understanding. It was supposed to be this year, but I don't know if that is still the case. Now, with this level of this volume of CO2 being captured, you have to figure out where that will go. It is difficult to think about 1 million tons from one single source being sold to, say, like the food and beverage industry. It's a really large volume. So here's where the question around large scale storage comes into play. And currently, the only way that it can be stored, and the way that the business model is making sense for this company seems to be to work with enhanced oil recovery, which is to take the CO2, pump it underground into depleted oil wells where you have been pumping out oil for a long time, so the pressure has reduced and no more, and to get more oil out, you have to repressurize it or make the oil sort of more viscous, and CO2 at a supercritical stage kind of helps do that and helps bring more oil out. It has been a contentious topic. However, there are studies out there that address this question of like whether that is net negative or not, and life cycle analysis in these kinds of situations will become super important to figure out whether or not you're actually removing CO2. So that's on that. There are also other kinds of companies that are trying to do this. Like for instance, Heirloom, they do what is known or what is referred to as passive direct air capture, which doesn't necessarily require all that energy to, capture 1 million tons a year, but it kind of uses nature to leverage what already is happening. Minerals that are out there in the world are already taking in CO2. This process is meant to enhance that natural uptake. And so you're kind of not necessarily using a lot of energy, you're kind of using low amounts of energy, and you're enhancing existing natural processes to make this removal process happen. And because it's also mineralizing into the rock, it is also considered permanent removal. So it never comes back up into the atmosphere. So there's just a different kind of a technology out there. So it's a range that I wanted to sort of share with you. With this level of innovation, you want to think about who's actually investing in innovation. And I read this in an article somewhere that it ranges from Exxon to Leonardo DiCaprio, which is actually true. It is a wide range of investors in this space. I want to highlight Carbon Direct is the first logo I placed in there. Carbon Direct Capital Management is the fund that it belongs to Carbon Direct. We recently closed a $150 million investment in growth stage carbon removal companies, and are looking to do more of this work. Breakthrough Energy is another, Microsoft is another player in this space. Shopify has committed a quarter of their investment fund into direct air capture specifically. And of course, we have further options like the X Prize for carbon removal that is currently reviewing. It's actually in process right now. They're reviewing applications for the $100 million prize purse. They're gonna award, I think, 5 or 4 companies with varying levels of money. I think it's gonna be like 50 million and 30 million and something like that per winner. About 3 or 4 winners is what I believe it's going to be. And this is the kind of innovation pipeline that is being built right now. And it's only going to get more, it's going to only get bigger, this market. And when I say market, who is really buying? the question is basically answered with, voluntary market. It's companies that are expecting in the horizon compliance to come about, or some sort of a regulation to report their emissions and to have commitments to to remove their emissions or to get to net zero. And so many companies who are aware and are sort of ready to take that step are in the voluntary market right now, buying up available credits, not just direct air capture, but all carbon removal. As you can see, Microsoft is a leading buyer. They have set themselves a net negative goal. And in fact, Carbon Direct works closely with Microsoft to work together in this approach. We actually worked with them to develop a set of criteria, quality criteria, that enables Microsoft to purchase credits from companies that are doing quality removals. And by quality, I mean removals that are meant to be durable, are not causing emissions to grow somewhere else as a result of reduction somewhere else, and are able to, you can verify them and it's permanent, and all those characteristics. And recently, after COP in COP26, I believe, there has been a recent emergence of this discussion around quality of removal offsets, because now everyone knows that most of the carbon removal offsets or credits available in the market, in the voluntary market, are of what is considered to be poor quality, because they perform low on, say, things like additionality. Additionality is when you don't know whether or not those credits, those removals would have anyway occurred, even if nobody paid for them, like forests. So there's a lot of review that needs to be done to really determine whether or not any removal is additional, and whether or not the money that is being paid for that credit is actually causing those removals to be, to actually occur. Leakage is the other thing which I mentioned earlier. Like, you don't want emissions to be going down in one place, but then coming back up somewhere else. So it's like, you don't want that to, the point is to make sure that there is a reduction globally. The credits should be durable and those kinds of things. The direct air capture as a category kind of tends to perform really well on those quality criteria. All things equal, they can be verifiable. They're, you know that they're permanent, durable. It's much easier to define that and to review that and understand that and clarify that that is meeting those criteria. So in general, because there's already a shortage of high quality supply of credits, the market is moving towards direct air capture. This is just where the market is going. It's more towards engineered and hybrid solutions, and direct air capture becomes a big part of that category. And what's happening is, because there aren't any existing projects, the market is moving towards forward purchases. So buyers are actually enabling projects to deploy in the future. With that, the market is only going to grow. We are nowhere close to where we need to be, zero. Like, we're at like thousands of tons, not millions. We're not even close. So we need to get to 10 billion tons of removal per year across categories, not just direct air capture. By 2050, we don't have much time. So the growth that is needed between less, it's like 40,000 tons being captured on a yearly basis today globally, to that number, it means that the market has to grow immensely, and will grow, I hope. And then we have to get to 20 a year after 2050. And as we deploy more and more of this technology, we expect to see the costs reduce. Right now, the costs are pretty high because we haven't had the technology go down the learning curve, but more deployment means more learning, and more learning means lower costs. Direct air capture as a technology will always be more expensive than, say, land-based or bio or nature-based solutions, but the truth is that this is an important part of the portfolio and will deliver results that other solutions can't, or other tools in the spectrum of carbon removal can't. It will have to be part of the portfolio. It will have to command a slightly higher cost, but we have to work towards reducing that to the extent possible. And I just wanted to make a small point about, thinking about direct air capture as a value chain. You can't only think about capturing of the carbon dioxide from the air. You have to think about the whole value chain, which is how does that CO2 then go anywhere else that it needs to be either utilized or stored or converted into something else? What is the transport mechanism, and where does it actually end up? And so even when we think about policies, we think about just the whole technology, we have to think about where the CO2 is going. Modeling suggests that a large portion of where the CO2 will end up is going to be permanent geological storage. But there are other mechanisms like mineralization and other opportunities that are available geologically across the world, and we just have to see more of those options develop. How do we get there? The US, this is a very US-centric slide. This is just a list of like $12 billion currently being allocated by a bill that was passed last year in December or November, US Infrastructure Investment and Jobs Act. Totally, I would say either directly for direct air capture or related infrastructure like pipelines and storage. Together is about $12 billion that is going to be spent over the next 4 to 5 years to push forward demonstration projects, to commercialize projects that are already in pre-commercial stages, or to get some pilots up and running on their track to commercialization. And that's a huge deal. This has never happened before. This is like the first time that something of that volume and that size has been allocated from the federal government. So there is a lot of intention to push forward direct air capture as a technology. And we hope that that, really materializes. And recently, New York had a procurement policy that they enacted where they said for meeting the state's greenhouse gas targets, they will potentially open up procurement for direct air capture credits, which means that potentially this is an opportunity for other states to do so as well. And in the future, it could even be the federal government themselves procuring to meet GHG targets. So basically, government as a procurement, doing procurement could also be a way to advance these projects forward. And lastly, I'd like to say that, that we already have some stuff in some policies in place, like the California LCFS, which is the low carbon fuel standard. The market allows for direct air capture to play, could be above $150 a ton in the market right now, but that fluctuates. And then we also have the federal tax credit, which is currently at a low volume. It's not necessarily built for direct air capture. It's built, the policy was designed for carbon capture and sequestration. But there are talks potentially in Build Back Better, which is a policy that the government is trying to push forward. There could be a separate tranche, much higher value, which is about $135 a ton for direct air capture. So that's still at play, and hopefully that kind of support can, again, together with all the above things that you can see on the screen, can push forward the industry at the rate that we need to. And with that, that's the end of my presentation. I'm going to pass it back to Joe.
Great, thanks so much, Deepika. And while you're changing slides and Natalie's getting her slides up, just remind folks to put your questions. The Q&A is easiest to track. The chat is a little bit harder to find good questions, so please put your questions in the Q&A. Great. Natalie, the floor is yours.
Hello, hello. Hi, everyone. We had some really good questions coming into the chat. So I'm excited to take those questions later, and I'll hopefully address some of them in this presentation. And thank you, Deepika, for your awesome intro to direct air capture. Some of the stuff that I have in my slides is a bit of a repetition, so I'll skip through that. But
Natalie, real quick,
yeah.
we're also seeing the slides on the left too.
Yeah, I'm going to go into presenter mode. I'm just the bar is covered by my thing here. Let's see. Sorry. Okay, is that working?
Yeah, great, thanks.
Great. All right, so Climeworks is a direct air capture company, and we've been talking a bit about direct air capture and why it's important. Just to reiterate this point, because I think it's really important to understand, in order to stay under 1.5 degrees of warming, we have a lot of carbon to remove from the atmosphere, and that's even if we hit our reductions targets. So Climeworks believes that reduction is the most important thing that anyone can do right now. So reducing our emissions, getting to zero, is super important. But even if we do that, there's a huge chunk that needs to come out of the atmosphere. And unfortunately, planting trees and nature-based solutions can only account for less than half of what we need to remove. So that means that engineered solutions like Climeworks need to exist categorically if we're going to stay under 1.5 degrees of warming. And I come from an ecology background, so I love planting trees and forests, and we need to scale those as much as we can in a smart way. But ultimately, we need engineered solutions that are built the right way, that run on renewables, and that can scale to take care of this issue. Quickly, I wanted to highlight the difference between carbon offsets and carbon removals, because the offset market has really developed over the past, 10 years. And it's kind of a dirty word. So carbon offsets are what we call avoided emissions. And essentially that's paying someone not to log somewhere else. So if I'm driving my car and I emit a ton of carbon, I can pay someone not to emit a ton of carbon in a forest somewhere. However, that ton of carbon that I emitted by driving is still in the atmosphere. So you need carbon removals to actually get to net zero. And that's the difference. Carbon removals actually take carbon out of the atmosphere that is in there. Again, so forests are super important and we need them, but the permanence of storage is an issue, and as is the land and water use. What's interesting when we think about the pricing, and Deepika touched on this a little bit, the pricing of nature-based removals is quite a bit lower than engineered renewals. We are coming down the cost curve, as she mentioned, but when you think about the current cost of a nature-based removal, you're looking at around $50 per ton to plant new trees for afforestation. It takes about 20 years for an acre of land to capture between 2 to 5 tons of carbon. So you're looking at essentially leasing an acre of land, half an acre of land, for 20 years, plus however long you're planning to store that carbon, for $50. So the economics of that don't really make sense when you think about how these are priced and the reality of land use and the length of time that you're trying to maintain control of that land for that price. So direct air capture, at Climeworks, we've put into place basically the first commercial scale facility. It is 4,000 tons a year, which is quite small. It's not exactly a climate relevant scale yet, but it's the first one in the world, and we're super proud to have that. And you have to start somewhere. So that's where we're at. Basically, what it does is it's these huge fans that pull air across a sorbent material. That sorbent material is an anion. It's basic, and it attracts the acidic CO2. We can then heat that up and vacuum the CO2 gas directly out of the collector containers. So Climeworks takes an approach that is very, I guess I would say, like morally pure to an extent. Like we run only on renewables. We don't have any rare materials or anything like that in our boxes or in our process. And we do not work with or take investment from oil and gas or any dirty industry at all. So we try to really, really kind of hold that line of we are not here to enable those industries to continue to exist. That said, folks who work in those industries have a lot of experience in building large scale infrastructure size projects. So if there are people who work in those industries who'd like to come work for Climeworks, we would absolutely love to have you make the transition. Okay, here's a representation of what goes on inside one of these boxes. One of the things that sets Climeworks apart is that we have a relatively low heat requirement. So we only require steam, boiling point of water, which is 100 degrees Celsius, which means that we can run our process fully on renewables. And that's because we have this solid sorbent instead of a liquid sorbent. So Carbon Engineering is the other company we heard about. They have a much higher heat requirement because they use a liquid sorbent. So our approach is a bit different, and it allows us to be modular and to run on renewable energy. I did see a question in the chat about taking renewable energy away from the grid. So first of all, I think it's important to assume that the entire grid will be decarbonized. It is imperative that that happens. So just as a starting point, like that needs to happen. But the truth is, yeah, direct air capture uses energy. What's really neat about direct air capture is that we can build these things anywhere. So we don't need water. The collectors actually pull in enough water from the ambient air to run the whole process. So we don't need water. All we need is access to essentially low carbon energy and then a mineralization storage sink, which are quite easy to find. So we can run this process in deserts or in places where there aren't population centers, but there is abundant potential to develop low carbon energy. So we're not necessarily going to be taking away from the grid in order to do that. So that's a positive thing. Right now, the plant operates at a geothermal plant in Iceland. We work with a partner called Climeworks, who has developed a really, really cool process to store the CO2 permanently as rock underground. So basically, they drill down to the basalt layer. Basalt is the second most common rock mineral in the world. So basalt is not hard to find. They drill down to the basalt layer. They inject basically bubbly water with our CO2 in it into that basalt layer. And then within 2 years, that turns into a carbonate rock in the pores of the basalt in a natural process. So that's very quick for a natural process to occur. And Climeworks actually can use seawater for that process. So they're really, it's really amazing what they've done. Highly recommend looking them up. Okay, moving on here. You can kind of see a picture on the right here of the rock itself, which I think is kind of neat just to see the actual rock. The little white bits inside of the black basalt are the CO2 that we've actually pulled out of the air. So in terms of commercialization, there are other questions about the market itself. Basically, right now, we're working with companies that have a solid reduction strategy in place, like Microsoft or some of the other big tech companies. And we are there for the portion of their emissions that are currently unavoidable. So they've reduced as much as they can, and then they're working with Climeworks and other removal technologies to take care of that unavoidable footprint. For those of you that are familiar with energy, our contracts are modeled after PPAs. So we have long-term contracts for offtake at specific facilities, but we also do work with individuals. So we want to give individuals the chance to participate and to remove part of their footprint. So we have a subscription, set up a subscription model where you can actually log in, choose what level you want to participate at, and remove part of your personal footprint. And I think we now have about 13,000 subscribers, which is amazing. Yeah, so that's not like the bulk of our money making or our revenue, but we think it's really important to let people be part of the solution, basically, and give people a way to do that. Yeah, so Climeworks is on our way. We're building our next facility right now. That facility will be 10x the size and is set to launch by 2024, potentially next year, but I like to add an extra year for any large scale project. And then we're planning to build the next facility at 10x the size of that, so 400,000 tons. And that facility will be built in such a way that it can be upgraded to 1 million tons by 2027. We've had a lot of support from the federal government in the US in terms of funding for building these types of facilities. So it's likely that that larger facility will be in the US. And our goal is to inspire 1 billion people to participate and remove CO2 from the air. We think that we can't wait for governments to make this a compliance market. We hope that that will happen, and we're doing everything that we can to push governments in that direction. But we need people to participate and to show support and really to make this happen, because ultimately, we don't think we can rely on governments to do it. That is my overview presentation, and I think we now have some questions to answer.
Yes, we have a lot of good questions. Thank you, Natalie, and thank you, Deepika, both of you. That was fantastic. Maybe since we sort of ended on the topic of the, or one of the topics there was around the personal subscription, which I think is really fascinating. Can you just give us an idea about what sort of costs, you know, if one of us wanted to subscribe, what does that look like in terms of cost per ton or something like that? Or what's the economics of that?
Or per pound, if that's easier.
Pound, or however you do it.
Oh, we do tons. Yeah, it's cost per ton.
Okay.
So currently our costs are around $1,000 per ton, but that price is coming down significantly. So we have a very clear cost analysis that has to do with scale. Like if you think about Orca, the Orca facility was built by hand in Europe and runs in Iceland, which is a fairly expensive place to run factories and facilities. So it's expensive, but again, it is the first of its kind, and it makes sense that it costs that much. And it, like, basically a really good analogy is solar or wind in the early 90s. So we know we can come down that cost curve basically once we hit a scale where we have that 1 million ton facility, and then we can replicate that. We can really see some major cost savings.
Yep.
Yeah, I'll say that we, I saw that you had included a link, Natalie, in your slides. We will send that out in the follow-up email. You know, at Electrify Now, we're all volunteers, so we have no stake in any financial stake, but we also don't shy away from promoting, you know, organization and funds like this that we really like. So I'm excited to check it out myself. Look into that.
Yeah.
Brian, you got a question?
Well, just maybe you'd follow up on that cost, because I think that, you know, interesting, Deepika, you had in your slides, I think you projecting getting down to somewhere in the low 124 or something like that was that by 2050? I can't remember.
It was not on time scale. It was more like if we get to a point where we've captured 2 billion tons using direct air capture, that means that you would have deployed the technologies enough number of times to get the learning that would then result in cost reduction. So that was matching deployment around 2 billion tons.
Gotcha. And I mean, if it would be interesting to overlay a social cost of carbon curve on that, or calculation, because I don't know, what is the U.S. government right now saying about social cost of carbon? I believe it's like $80 a ton, if I remember that correctly. It's been going up. I mean, I think even 80 is probably underestimating the real cost, but is that the official number that's being used at the moment?
I mean, if you look at the 45Q tax credit that's being considered, like you're looking at, I think it's $130 or $150 per ton. So most people who are really thinking about the cost of carbon are landing closer to 200.
Yeah.
And I think someone in the chat said, like, we're living in a world where the true cost of goods isn't accounted for, and that is true, and it's going to be an interesting reckoning as that starts to happen.
Yeah. So I guess where I was tracking with that line of thinking is, it seems like, and I think you're validating this, that it looks optimistic that the cost, the potential costs for direct air capture will be well under the social cost of carbon. At some point, those lines are going to cross over where, you know, the costs come down, and social cost of carbon is probably just going to go. It's going to go up and up. There's nowhere else for it to go. And so the closer we get to, you know, 2050, it seems like that cost is going to increase. So I feel like that's encouraging. You know, it still feels expensive, but it relative to that metric, it looks encouraging.
And on that note, with the cost, I mean, I was following the chat, and JS had an interesting point that, you know, back of the envelope calculation, that $124 per ton times 20 gigatons is 2.5 trillion a year. But Natalie, do you want to say how your response was really interesting in the chat? How would you respond to maybe spending trillions of dollars a year on sequestration?
Yeah, well, first of all, like it has to happen for us to stay under 1.5 degrees of warming. So like arguing about the cost of it is like almost a little bit of a moot point. But ultimately, like I think Saudi Aramco's annual market cap is over $2 trillion. And that's just one company in the oil and gas industry. So it makes sense that it would cost a similar amount that it did to put it in as it does to take it out. This has to scale to massive scale. And I think that's something that is intimidating to folks sometimes when you think about the scale of the problem and what has to happen. We need to be the size of the automotive industry in terms of manufacturing our collectors. And we need to do that by like 2030. But it's basically like an imperative at this point that CDR scales to that level. So we need to plant, we need to plant all the trees we can. And we need companies to reduce their footprints to zero because frankly, we have enough to do with the residual emissions that are already in the atmosphere.
You know, that's interesting, you know, the analogy to the automobile industry. I wonder, because some of the other interesting questions in the chat had to do with the amount of energy it takes to do this. And of course, you know, there's this question about, and you addressed it, about sort of siphoning energy off from other uses that would avoid carbon. But let's ignore that for a minute and just, could you give us an idea, like at the point where this technology is at the sort of scale that it needs to be, so it's going to absorb a lot of energy, but to do that, but can you give us an idea about how that much energy that would be required relates to how much energy the world is using already? You know, like, are we talking about, is it 50%? I doubt it's anywhere near that high, but I mean, do you know what I mean? Do you have any thoughts about that, about how to put in perspective? Because you were just talking, like, the automobile industry is a really interesting reference. And if roughly speaking, it takes that quantity of energy to run the carbon sequestration thing, then that seems doable because it's like, we're doing that now. But do you have a way of like just kind of giving us some reference points for that amount of energy that's needed?
Brian, I can provide some perspective. I don't know if this is going to be helpful, but if you think about the emissions by sector, right now, close to a fifth or a quarter of our emissions come from the industrial sector, which is making all the stuff we use, making our clothes, making our, you know, water bottles, making our phones, making our laptops, just everything that we use, including things like cement and steel and all that. So just industry is responsible for a quarter of our emissions. So I would even like use that as a reference point to answer the question that you're asking, because this is going to be making stuff. Like the collectors need to be made, the pipelines need to be built. Like we need steel, we need, you know, trucks to carry that stuff. So it's automobiles and
ultimately, like it's going to take a lot of energy. And I think, like, again, like this is a question that keeps coming up over and over again. There are a few folks who are quite interested in this audience, and like we need to decarbonize the grid completely, and that's going to take a lot of different technologies to get there. Like I recently learned about a company called Quaise Energy that has developed a new drilling technology that they can use to basically access geothermal anywhere. So we have to operate under the assumption that like low carbon energy will be available and will be abundant, and that those technologies need to develop. We don't think that developing this at the same time takes away from the importance of developing that. And in fact, like we can provide new market opportunities for some of the bigger developers to develop more supply, because right now it's actually they're hitting a point where it isn't necessarily making sense financially for them to bring new supply online in places like the United States. So there's that opportunity. There's also the opportunity once we get to a certain scale and our costs come down in terms of the CapEx for deploying the projects, that we could be a solution that's used when there is excess energy in the grid. So, you know, during the day when there's lots of solar. Right now, that wouldn't make sense because the CapEx is pretty high because we don't have the supply chains in place yet. So right now it makes sense to try to run these things 24/7. Also, we're learning a lot from every deployment, and we're really at a very early stage of development. We're at a stage where we've done the research, we have a technology that works, and we're trying to figure out how to scale that and how to deploy it at scale. So right now, we're going to be using a lot of energy, but it could be a solution to take off excess energy at certain times during the grid as well.
Another thing I'd like to add to that is that we should, I think, not limit ourselves to looking at this as something that will need energy. But another business model that I'm seeing appear as, say, for instance, carbon engineering has this other business line, which is air to fuel. So it's almost like using the CO2 that they capture from the air and converting that into energy. But it's liquid fuels in this situation. And I think that they're still, I don't know how far they are or if there's just a pilot right now, but they're actually using this technology to make energy rather than use energy only. So I think that there's another paradigm here that we need to understand, that there's possibility of generating synthetic fuels or synthetic crude for jet fuel applications that could then make flying carbon neutral or potentially carbon negative, given that you've actually utilized air to carbon in the carbohydrate that's actually running the flight, and the emissions that come back are just recycled, and that will make it carbon neutral. So that's another paradigm at play here.
Yeah, the PTX market, so the power to liquids market, is quite a bit smaller than the market for just carbon removal and storage and permanent storage. So that's why we're really focused on that right now. But we do have a test project that is happening for sustainable aviation fuel. The issue with sustainable aviation fuel is that, like, thermodynamically, it requires quite a bit of energy to make that conversion. And in order to get the blue or green hydrogen that you need for that process, you're paying about $1,000 a ton for that, plus the $1,000 a ton for what we're doing. So it just doesn't quite add up yet. Yeah, if I was an airline CEO, I'd be worried. But I do think that there could at some point be a pathway to that, but these other technologies need to scale first before it becomes like a really viable thing.
There were some questions in the chat also just about rather than just storing the CO2, about other uses, like potential, I guess, plastics potentially, or other things. What I seem to have heard that there isn't enough even plastics in the world, even though there's so much of it, to store all the carbon that we need to store. So that might be partly an issue about scale. But can you speak to this, like other uses besides just permanent storage, like underground storage? What's going on in that area?
Yeah, do you want me to start?
Sure.
Go ahead.
Yeah, there are a lot of different things that you can do with carbon once you pull it out. So the gas that comes out of our collectors is like food grade, so you could put it into a Coca-Cola. You can, and carbon is used for many industrial processes. Like, again, so we feel the most important and the best thing that we can do is to store it permanently, as permanently as possible. And additionally, right now the costs are so high that it doesn't really make sense to engage in any of those other projects. That said, we do have like a research scale facility at our headquarters where we sell a tiny bit of CO2 to Coca-Cola and a tiny bit to a local greenhouse. So greenhouses are another great way that the CO2 could be used. Or we could maybe develop partnerships with companies like Carbon Cure, who are injecting that CO2 into concrete and storing it. So there are a lot of really cool things that could be done.
Yeah, I do want to, and this is not going to be music to anyone's ears, especially not this audience, but the important thing to remember, which is what I highlighted in my last but one slide, which is that we need to think about where the CO2 goes. And if you think about large scale consumers of CO2, it happens to be the enhanced oil recovery industry. Currently, if you think about the market for CO2, the biggest buyer and utilizer of CO2 is the oil industry themselves. They use it to pump it underground to get more oil out of the wells that they own. And that is the one industry that is willing to pay a really high price for it. And that's what we need to.
Sorry to interrupt, but what is the source of that CO2 now?
Yeah, so that's interesting that you asked that question. 3/4 of the CO2 that this industry ends up using is actually already underground. So they're literally going to these CO2 domes where CO2 exists naturally, nicely underground, not having anything to do with the atmosphere, but taking it out and then getting more oil out, which then puts more CO2 up in the air. So it is definitely a very it's definitely a net positive. It actually puts more CO2 up in the air, and that's not what we like. That's not what we want. That's not going to be a solution to climate change. And so what we need is to reverse that. First things first, that natural CO2 use has to stop and needs to be replaced with industrial CO2, potentially captured from a coal-fired power plant or something that is emitting nearby, or the air. Just that it will really matter, how much these things cost, because you're replacing a relatively lower cost source.
Gotcha.
But things like mandates in terms of limits on emissions, mandates on going to zero, and potentially also incentives to reducing emissions are all going to be tools at our disposal to change this and reverse this.
So it sounds like just to paraphrase a little bit, that this enhanced oil recovery, using carbon capture for enhanced oil recovery is like a reduction strategy. It's like a carbon reduction strategy, which is a good thing. We need that, but we shouldn't confuse that with the destination that we're trying to get to one day, which is that we don't need that reduction strategy because we're not using fossil fuels, and we can use direct air capture for true sort of drawing down of legacy carbon. So it feels like we shouldn't ignore it as an interim step that's pretty important, it sounds like, but it's not. That's an interim step. Maybe that's the true bridge fuel thing that people talk about with natural gas.
Yeah,
I want to reiterate, it's really, we don't have a luxury to choose our solutions. I think it's just I think that we have to get out of the mindset of we need only this technology because we love it. At this time, we're so close to 2030, we're so close to 2050, and we have so much work to be done. None of these technologies, both reduction and removal, we have to adopt and embrace all and push everything down the learning curve so it gets cheaper and we can deploy widely. I personally want to sort of caution against this mentality of it's like this is going to be a bridge or this. At this time, everything's everything's at the table right now. It's just, this is me wearing my nonprofit hat, maybe because I used to be at a nonprofit, but it's just unfortunately that's where we are right now. It may not be what everyone loves to hear, but I don't mind being the bearer of bad news. Climate change.
That's appreciated. That's appreciated, Deepika. That's a good point. Well, I think we have time for a couple other questions. I one here from Mike and Marge that maybe Natalie can take the first stab at. But Deepika, you weighed on this last year too. But we're talking about direct air capture today, but according to them, and maybe you can confirm this, that capturing CO2 where it's at a higher percentage coming right out of a cement smokestack or from a kiln or whatever they emit the CO2 out of would be more efficient and more cost effective. Why does Climeworks go for the direct air route versus the point source route where you're capturing it there right at the source of pollution?
Yeah, point source capture is awesome and needs to scale. Also, there's a great company called Svante, which is doing some awesome work in that space. And you're right, the concentration is higher, so all of the resources required to do it are less. But unfortunately, we have two problems. So one is for some unavoidable emissions, such as airline travel, where those point sources are distributed, then you need something to pull that out of the air elsewhere. But additionally, as we said before, there's so much carbon that's already in the air that all those legacy emissions that need to come out, point source capture won't take care of those. So point source capture is a reduction strategy. It reduces the amount of overall CO2 that is emitted, whereas direct air capture is a removal strategy. So it removes CO2 that's already in the atmosphere. And just really quickly, I wanted to touch on the enhanced oil recovery conversation a little bit more, because I feel like we've been focused on that a lot, and we do not do that. And I just want to make that clear that philosophies vary on the importance of that. And we at Climeworks don't think it's an important step towards scaling direct air capture.
Thank you. There were quite a few questions about the cost, the kilowatts of electrical demand required to capture 1 kilogram of carbon. Do you have that some kind of rough number like that on the top of your heads?
I don't have that off the top of my head. And also, like, to be frank, with the scale of facility that we have now, it's going to be more than it will be in our next iteration.
Yeah.
That number is coming down.
Gotcha.
Yeah.
Great. I mean, there's lots of things that we could. I would love to dive in a little bit the offset market conversation. We've had a little bit of conversation about that, but it sounds like that is a developing situation, that there isn't really a well-established carbon offset market that you're able to play in at the moment. But can you just maybe speak a little bit more to that? I know you touched on it, but I'm just not sure I have a good picture. It sounds like some of the progressive players are looking at investments in this area as almost like a way of doing satisfying some of their voluntary offset compliance. But what is it going to take to get to a real market in this space?
Yeah, so the voluntary market is certainly developing and buzzing along. Like we are closing deals with big companies, with small companies, and they are anywhere from above $10 million to $3,000. So it really varies, and the interest is there. The real issue right now is the supply. So right now, carbon removals are a very supply constrained commodity, if you think of it as a commodity. There are Microsoft estimates that there are 8 million tons available, and Stripe estimates that there are 12 million tons available. So somewhere in there is the right answer, and that's just not enough. So basically, we are executing these forward contracts that pay for offtake at our next facility, and what that allows us to do is to unlock other funding that lets us build those facilities. So the companies get the benefit that they have part of their footprint secured towards their net zero goals, and they have some of that supply taken care of, because again, it's really hard to find that supply, and we have the benefit that we have long-term contracts that we can then show to investors. Yeah, like it's a super interesting market right now. It's developing really quickly. There's a lot happening on the government side, as well as on the private side. These organizations like Science-Based Targets Initiative, which are creating rules that companies are following in the voluntary market, and we're working really closely with them to make sure that high standards are set. So we want to make sure that, like, additionality, which we talked about a little bit earlier, is touched on, permanence of storage, efficiency, like all of these factors are taken into account when these technologies or these specific solutions are evaluated.
Yeah, I mean, it does seem, and you mentioned this, I think both of you touched on this, is that one of the advantages of direct air capture is that it seems like it's going to be easier to verify it, and also to feel confident about the permanence thing, which is tricky with most other solutions. Joe?
Sorry, I was muted. Scott has a question on the cost. Is the high cost of direct air capture right now due to the capital expenditures or the operating expenditures? And how would we bring those costs down?
Yeah, like I can't give you exact numbers without an NDA, obviously, but we have a clear picture of what that is and a clear path towards bringing those down. So yeah, like it's part each. A lot of it, like if you think about early stage projects, it's often higher on the CapEx. So that would make sense if that were true.
As they scale, then that
Yeah.
would fall.
Mm-hmm.
Great. Brian, do we have any last question to take us home for? Oh yeah, Deepika, I see you're answering in the chat right here. Michael's asking, is there a limit of geological storage for the CO2? Is that going to be an issue?
Economically, there will be a limit as long as we can find an economic way of getting to those storage sites, but geologically, no.
Yeah, and for us, we want to co-locate at storage sites. So we're going to build our facilities at places where that storage already exists. Actually, in Iceland, there's enough storage under that one facility to store all the CO2 that humanity has emitted since the beginning of the Industrial Revolution. Now there's not enough energy or land there to do that, so we won't do it all there, but it's basalt. So like most of the ocean floor is basalt. The whole Hawaii is basalt. Like the basalt isn't hard to find.
Yeah, I also understand the saline aquifers are another good place. Is that correct for?
Totally. Yeah. Yeah. That's an interesting one because there are a lot of these like private equity firms and other firms that are sitting on empty, basically sites that could be used for saline storage. So it's silly to think that those won't be used, and it is a permanent solution. The wells are much deeper than with Carbfix's method, and the pressure required is a lot more, and it takes a little bit longer to mineralize. So we hope that Carbfix and other solutions, like there's other mineralization solutions, come to the fore. Another really cool one is 44.01 in Oman. So that's another project that does mineralization storage using another pathway. But yeah, that industry is developing and just exploding right now. There's a ton of really cool stuff happening.
Yeah.
Yeah.
Great. Well, maybe ask both of you if you have any final thoughts for folks to take away on where we are and where we're heading with direct air capture.
I'll just say that direct air capture is super important. We have to see it expand. We want to see more companies, more types of direct air capture companies. We need more shots at the goal. So I would say, so ask your local, policy person to support more advancement on this technology, and go ahead and do your part if you feel like. Sign up on Climeworks, I guess.
Yeah, and there's a procure, for those of you who are in New York State, there is a statewide procurement bill that was introduced for carbon dioxide removal in general. So it's technology agnostic, which is great because, again, more shots on goal, and it encourages all the different technologies to be able to participate. We think it's a pretty well-written bill in terms of having high standards. So if you live in New York, support that bill. Yeah, those are definitely things that you can do as an individual.
Or get that bill to be done in your state.
Yeah, totally.
Great. Well, as we always like to remind you, we'll send out the slides and important links, especially, check out Climeworks is offering to offset your own CO2 in our follow-up email tomorrow. And want to thank Deepika and Natalie so much for being such fantastic panelists and sharing their knowledge with us today. Brian, anything else?
No, that's great. Thank you, Deepika and Natalie. That was fantastic. And thank you all for tuning in today. And if you have any questions about your own electrification projects, feel free to reach out to Joe or I. Our emails are on our website. And good luck with all your electrification projects. And hopefully we'll see you at one of our other interesting webinars either later this week or some other time. So thank you.
Thank you.
Thank you. Yeah, thanks, Deepika. Good to see you.
Good to see you, Natalie. Bye.
Bye.
Thanks all.